here we're going to find the sum of some series. Remember, a series is a sequence added up, so sum of a sequence. Right, so in here we're going to have a look. First of all, we're going to look at part A. Now, if you look at this sequence, the sequence goes 1, 2, 3. The first few terms. So the sequence is just the sequence of integers. So, and the way we put integers for our sequence is the first term is 1, the second term is 2, the third term is 3. So it's just R. That's our sequence. Now we want to find the series, so they've all been summed up from R equals 1. That's the first term. Right, so the rule is just R. Now if you have a look at the other end, we're going on and the last term is 3n. So how do I get 3n when the rule is R? Well, that means my last term must be the 3nth term. So I want to add up from 1 to 3n. Right, now I'm going to actually find the sum once I've written what I want. Now in order to find the sum, there are some in your formula book. There are some helpful formulae, but the sum of R isn't there. This is one you have to learn. So the sum of R from 1 to n is a half n plus 1. So that's the formula. And you can see here we haven't got n. We are going up to 3n. So that means instead of n I've got 3n. So it's going to be a half times 3n times 3n plus 1. So just simplifying that a bit, it's going to be 3 over 2n times 3n plus 1. Then we can look at part B. So this time, if you look at it, the rule is take the term number and square it. So the way I write that rule is r squared. Sum from r is 1, so first term put 1 into that formula. And this time you can see that the last term, the one we want, is to go up to the 2n minus 1th term. Okay? So we're adding up to 2n minus 1 because I've got 2n minus 1 squared, which is in our formula. Okay, then we do, this one is in the formula book, so the sum from 1 to n of r squared would be a sixth. Now instead of n, I've got 2n minus 1. Instead of n, so now for n plus 1 I'll have 2n minus 1 plus 1, and then the last one I want to do 2 lots of my n, which is 2n minus 1 plus 1. All I'm going to do is simplify that, so a sixth. I can't simplify 2n minus 1. The next bracket's going to become 2n, and the last bracket, if I expand that, I get 4n subtract 2 plus 1, so minus 1. Just by convention, we could then simplify that. We'd write the 2n at the front, so I get 2 over 6, which is a third, times n, 2n minus 1, 4n minus 1. The last one, you should be getting the hang of this by now. You can see that the rule is r cubed, because we go 1 cubed, 2 cubed, 3 cubed. We're going to sum that up from r equals 1, and this time again, the last number we sub in is 2n minus 1. This one is in your formula book. It's r cubed, so that's a quarter times whatever n is, the last one we're adding in, so that's 2n minus 1 squared. And then n plus 1, so that's 2n minus 1 plus 1 squared. And then we're just going to simplify that. And this can be simplified even further. Good. 4 is going to cancel. And there we go. That's how we can add up this type of series. Just an amendment here, so hopefully you've spotted the mistake that was made in this last one, which is when I squared the 2, forgot to square the n, so of course that formula should be n squared 2n minus 1 squared.